Okay. Check, check, check. That's the wrong one. Actually. Okay. So pretty quick stream here because I have a meeting in like an hour, less than an hour. So I just wanted to try and get a print going, see if we can get it done in time. So this is going to be a bit of a speed round. I also wanted to show you something that I did print. This actually, let me before I get there, let me just double check the stream here. Sorry. Oh, okay. Wait, I'm gonna go like this because I don't know. Don't wanna. YouTube. Boom. Okay, everything seems to be working. Clean my camera. Clean this camera. Okay, so the main thing I wanted to do here is none of my printers are going right now, so I really want to get a print going before my meeting in like 45 minutes. I did print this though. This is a new string idea. So if you see my other videos, I have a bass and a little guitar thing. And the bass is a TPU tube that I printed and inserted a full piece of filament before completing. I paused the print, put the full piece of filament inside the tube, and then resumed the print, and it printed the rest of the tube over top of the filament. So you get a filament cord TPU string, and it works really, really well for the bass. I'm super happy with the bass. But the guitars, I was just using a regular piece of filament, and they sound okay, but they're a little bit plasticky sounding, obviously. So I want to try and get some more high ends. So let me show you what I got here. Okay. So on this build plate, I'll go full camera here. We have printed a big spiral, and this is Polymaker COPA nylon. And I just wanted to do a quick little example here. So let's pull this off because that's what I have to do anyways. Actually, let's do this so that you can see. So this stuff, comes off so nice. And I printed this super long string for a reason. This is obviously way longer than I need. Hopefully my cat doesn't try and attack this. Woo! This is so satisfying. Now I've been using this filament as a raw filament on the guitar as a test because when I got it from Polymaker, I specifically got this filament because of its tensile strength, which means it is really, really strong when you pull on it, when you put tension on it. And so I just wanted to do a little bit of a comparison, but I have so much of this from this spiral. This is actually crazy. Hang on, let me just be right back. Just grabbing the roll of filament so I could show you. Okay, I accidentally loaded filament instead of unloaded. Okay. Here is, if you have a bamboo printer, you recognize this. This is just a little, it's like its little um, extrusion piece that it does at the beginning of every print. This is PLA, and it's about the same diameter, or it's about the same size as the stuff I just printed. And you just pull it, snaps, right? That's what's to be expected from PLA. This stuff, let's just grab this. Let's see this tiny little bit of string here, and it's so long. I have such a mess down on the ground there now. So let's see how hard this is to break. Okay, it still broke, but it is considerably stronger. Like, this is like, you know, I really gotta, and you can see it does that too. Whoa. So that time it didn't even break, it just stretched. And this is even like, so the reason I printed a thin little strand of this is, one, I want some thin strings on the guitar, so I'll be able to use that. But two, I'm gonna try winding a bunch of this together to make the different thicknesses of strings, because I have a guitar that has 4 strings on it, so I may as well try and make it each string a different thickness. So that is the plan. And I have this whole mess of string now that I can do that with. Oh, I shouldn't have done it this way. This is an absolute disaster. But that's okay. So I might do this on another stream, the winding. But right now the goal is to just print some more cymbals. So give me 1 second. I'm just going to put this away. Just for reference, this is the COPA stuff. I keep it in a dry box because nylon is extremely hygroscopic, I think is the term. So it absorbs moisture really quickly and really easily, and that ruins the print quality. So keep it in a dry box. I can go throw it on the dryer right now because we're at 18%, which isn't great. I'm going to go dry this and load up the PPSCF. Give me 1 second. Okay. Okay, so I really want a proper cymbal sound. These have been my attempts so far. Super thin sheet, honestly, sounds kind of the best. It's just like a splash, right? And I have put that in the song, and it works. But obviously, it's not the sustain of a cymbal. So I tried it a bit thicker. We lose pretty much all the high end. This does, when you hold it right, you know, it does sustain. And when you hit a cymbal, a real cymbal, like a brass cymbal, you do actually get kind of this low end sustain underneath. But it also does, the dominant sound is the super high pitch resonant frequencies that it resonates at. So this doesn't have any of that. So then I tried this design, which honestly I just wanted something that looks really cool, and this looks so cool to me. And the idea with this was all these thicker parts were supposed to help vibrate the cymbal, and then all these thinner parts and like these little shapes and stuff I wanted to resonate at a high frequency. However, and it is a little better, I think. I think it's a little bit better. Especially right there. But I think that's actually the bell. That's and these thin surfaces, they end up vibrating at the same low frequency as everything else. So it's not that high. Then I tried printing this guy, and this is basically a bowl that has all these little bits. These are actually like little broken bits that came off the bottom of this because I accidentally peeled this off too early. Has a really nice sizzle. Unfortunately, the low frequency is far more dominant. So I can't really use this. I have used the high frequency a little bit, and if I could EQ, I'd probably be fine with this. But because I can't EQ, I can't get rid of that fundamental tone. And so I did a little bit of research, and I think what the issue is, especially with something like this, is while it has, a bunch of complex shapes in it, this outer rim is extremely uniform. It's the same thickness all the way around for the entire height. And so what that means is when this vibrates, it's vibrating at one fundamental frequency way more than everything else. And yes, it vibrates everything else, but it kind of takes over, and that is the dominant frequency. Right? So a regular cymbal is designed with it technically has, like, brass is just so much better. Like, brass basically doesn't, compared to plastic, even this PPSCF stuff, brass is just so much better at converting vibration into sound, and it does it at all the frequencies really, really well. So I think the key is I need to create a disc that has a varying thickness throughout, and I think I need the bell to be extremely thick, because this PPSCF stuff, while it sounds like metal, it's still nowhere near the efficiency of brass when it comes to the vibration. So I want to try and come up with a cymbal that has a lot more variance in the thickness. And basically the idea would be to have it super thick in the middle, and then have it taper out really, really thin to the outside, so that when you hit it, the middle sustains the vibration for longer, and that's how you get the sustain. But then that vibration tapers out and gets higher and higher as it reaches the edge of the cymbal. And another factor is I need to print this in a shape so that it maintains tension throughout the cymbal. So you'll notice when I print anything flat, it kind of does this taco thing. And I think that really kills the resonance of it. You can see there's an inherent tension in this material. And so that's why a regular cymbal actually has a very slight sort of taper to it. Now that's a problem, because I can't really print something with a taper like that without having a crazy amount of support underneath it. Um, and I did want to experiment because I have the H2D, which has the two nozzles. I could theoretically print a different support material than the PPSCF. The what I've noticed, I think I did a couple prints that required supports with PPSCF, and the supports weren't that easy to remove. So I imagine a giant disc with supports would just be an absolute nightmare. So if I did want to do the support thing, I would have to probably use a different material, which I don't think any of the materials I have on hand would make sense as a support because the chamber temperature and the bed temperature and the nozzle temperature has to be so hot that I think this stuff would just melt those supports. I believe Polymaker does have a specific support material for this stuff. I didn't get any of that though. So that'll be a future project. But instead, I think we just need to play with the geometries a little bit to try and create some internal tension in the design. That's going to be a lot more. That's going to be able to print without supports. So, thinking of that, and then I need it to taper. I need it to vary in thickness. I need the edge to be the thinnest. So, how do we do that? I don't exactly know. What I'm going to do, though, is I'm going to start by grabbing one of my cymbals and copying it. Because I know this is the size I have to work with. And I'm going to go ahead and do a sketch on this surface. I'm going to project this shape. And I'm going to extrude this down to get rid of all this stuff. This is what I did last time as well. However, excuse me, I am going to, I think I'm going to get rid of this whole like rib structure thing as well, and basically just keep the bell. But I'm also going to thicken this bell up quite a bit. So I think we can just do a push-pull. Oh, wait. Press-pull. So let's thicken this right up. Let's make it like considerably thicker. I still have quite a bit of PPSCF, thankfully. Okay, now that is a fat little bell. Yes. It's a fat little bell. So one idea I had was to do a spiral. And spiral cymbals exist. They do exist already. And that's kind of why I'm thinking about doing it. Plus it'll look cool. So let me show you my plan here. So actually, can I just pull up a... Yeah, see, they exist. Oh God, sorry. I'm so bad at streaming still. So spiral cymbals exist, and for my research, what's nice about a spiral cymbal is I can print it flat, but when I hang it, the gravity will be pulling the spiral downwards, and as a result, that will add the tension that I'm looking for instead of trying to print a bell or instead of trying to print like the taper. So, okay, so I thickened the bell. I apologize, I didn't show you any of that, but none of that was important. So let's do a spiral. I really don't like the dark mode of this. I don't know how to change that. Graphics? Don't know what dynamic does. I don't know. I don't know how to change. Oh, here we go. Theme, light gray. Yeah, this is easier for me. This is much easier for me. Okay, this looks better. And I am still going to change the material of this back to that. So that's a lot easier to see. So we're going to do a spiral. So you do a coil, and we're going to do it on this surface. And I'm going to do it from this point. I'm going to go there, and it's going to go. And I have it. I have the type. Whoa, I'm so confused. Okay. I have the type set to spiral already. Normally you do coil, but I'm going to set it to spiral. And like this is already pretty darn close. Now the 3 revolutions is probably okay. Diameter, that's about the same. I can make it a little bit bigger. Let's do like 100. Okay. We want to go inside, right? I don't really know why it's doing it like that. And we're going to do a new body. 3.5 revolutions. Is that going to fit on my printer? Yeah, that'll fit. Okay. I don't remember what a pitch means. Why is it doing pitch? Okay, wait. We can do section. Let's do 25 mils. Okay, let's go 30. Yeah. Let's get it close. 32. Okay, let's do that. Right, that's a good shape. Now, obviously, this is thick AF, so let's bring this down. And I want to go just new body it. Or no, yeah, let's just go new body for a second. And I think I want the thickness of this. I'm going to press pull this up until we're, matched with the bell there. Sure. Don't know. That's good enough. We can match that later. And then we're going to do another press pull. Get it even thinner. Let's maybe go for that. Let's go for that. Now I need to taper this. And how do we taper it? I do not know. I actually have no idea. How do I make it so that it stays thick as possible up here? If I press pull this, does it? Okay, weird. Well, that's pretty good, actually. That looks pretty good. So how do we taper this slowly? This is where I would love some Fusion 360 pros on the chat. I guess I'll fillet this while I'm here, just so that we're, looks good to me. Oh. I'm gonna... Oh, shoot. Okay, Fusion's not like me today. Project. I want this inner circle. Boom. Okay. I just need to cut a hole in this. Extrude. No. Did that work? What am I looking at here? We can just go like this. I should have just done this from the beginning. Okay. Right, we want that to be hollow. We bring that in. Nice. And then we can combine this by going like this down to here, joining it. Boom. Great. Now we've got a solid body. All right, I like this. I know this bell can print fine because I've done it lots of times. So the taper, like what, like honestly, what happens if I just, actually let's get rid of this fillet. What happens if I just chamfer this? And I go to distance. And obviously this one, we want to come up like that. See, this almost works, but it doesn't follow. It doesn't follow, you know? It just goes in a straight line, so that's not going to work. This is a tough. This is a difficult problem. Now, what if I created a separate coil? Can I do a spiral with some lift on it? I don't think I can. What time is it? Ooh, okay, I've got like 15 minutes. You know what I mean? I need it to be really thin here, and then as it wraps up around the spiral, it gets to its maximum thickness right about here, or even here. How do we do that? How do we do that? This is great. Like this is how we become fusion pros. We will get there. I just don't know how yet. I want to be a fusion pro, and I really wanted to get this printing before my meeting, and I might work on this during the meeting if I need to. See, like I think it's some sort of revolve. No, it's got to be some sort of sweep, because I can draw a path with a sweep. let's ask Gemini. In Fusion 360, I want to create a spiral body that tapers the thickness along the path of the spiral. I want the outermost part of the spiral to be the thinnest, getting gradually thicker until the center of the spiral. I hope that makes sense. It can be a bit tricky because standard coil tools allow for variable thicknesses along the path to get that smooth transition from thin. The sweep tool with a guide rail or a loft is your best bet. Here's the most reliable method using a sweep command. Create coil, select your diameter and revolutions. Crucial, set the section to none if available in your version, or simply create the coil as a new component so you can use its edge. On the start and end thickness. Okay, actually, I think I just figured this out. The loft tool is the way we want to do this. So I'm gonna go back. No, I'm not gonna go back. We're just gonna basically stop at this point. So I'm gonna sketch here. I'm gonna project this, and I'm gonna draw a line from the center to here-ish. Boom. Right? Finish. Okay, and now I can go like this. Cut this off. No, I'm going to cut it. Because I can just bring that back, right? Yeah. And then I'm going to actually go back into the sketch, and I'm going to project this. Oh. Okay. Then I'm going to delete this fillet that I did. And I am going to do a new sketch. Get rid of all these sketches that I've done. And we're going to do it on this surface. And I'm going to project the body. Boom. Okay. So this is going to give us rails. Very important. Oh, wait. I need to project the... Oh, wait. Okay, I got to do the sketch plane on the bottom. Create sketch on the bottom, and then project the body. Okay. Finish sketch. And then I'm going to go here. I'm going to create a sketch here. I'm going to do my thin rectangle, which will be... Let's go, 0.35 mils there. Finish sketch. Now, if we do a loft and we grab this profile, boom, and this profile, boom. Okay, already wants to do it, but then we grab some rails. I turn sketches back on. Make this more clear. think I got to go back into the sketch. And I want to delete this one. Boom. Yeah. And I want to delete this one. Boom. Yeah. Finish sketch. And then we go back to our loft. I don't know if this is going to work. I don't know if this is going to work. We grab that. And we grab that. And then we do rails. See, why does it want to... Oh, chain selection. We don't want that. So it's still chaining. Oh, no, it's not. It's not chaining. Did we do it? Did we do it? So I don't want to cut. Let's just do a new body. Okay. And then if we hide this... What? Oh, the loft didn't work. It looked like it was about to work. The loft would intersect itself. Try changing the inputs. Okay, let's do another rail. Add a second rail. Yes, this one. Rails cannot be tangent to profiles. It's not tangent, though. Ooh, it is messing up. Gosh. I thought this was going to work. I thought this was going to work. New body. It's not happening, folks. Okay, I got to jump into my... Oh, no. We still got some time. See, why doesn't this work, though? I thought this would work for sure. Cancel. Can I do the same with a sweep? I think I can only choose one profile with a sweep, though. Oh, no. Let me choose it. Yeah, I can only do one profile. What can I do? What can I do? What can I do? Let's see what Gemini said. So draw your profiles. You need to define the start and end thickness. Create a sketch at the outer end of the spiral path. Okay, wait. Actually, let's see if I can just do this by getting rid of the body. So I need to create a sketch of this, and I just need to project this. Okay, and then if I get rid of the body, doop, finish sketch. Now we have this. And then I create a loft between this and this. And let's just make it a new body, just so it's a little easier to see. And then we grab our rail. Boom. It's so close. What is happening, though? What is all this nonsense? And then even if I grab a second rail, nothing happens, hey? Second rail, nothing happens. Or something happens, but it's doing crazy stuff. Analysis? I don't know what analysis does. You'd think this would work. Why is this not working? Closed? How is this tangent to the profile, though? I guess it's saying like this rail is tangent to that. I guess I don't know. Okay, that doesn't work. What do I do? I should have just done the string on this stream. I don't know what to do. Right, I just need this to... Like a sweep will work for sure. Yeah, sweep works. Sweep works great. So what's happening here? Well, we're going to come back to this. I'm going to get ready for the meeting. I will see if I can work on this during the meeting, like just figure it out, and then I'll come back and we'll see where we get. I might do nothing. I might come back and there's none of this ready. So, yeah, we'll